Stan Gibilisco here, just briefly looking at another way to define the trigonometric sine and cosine functions, a method you probably learned before you learned the unit circle model, which I've done in another video. If you ever learned the unit circle model at all, the right triangle model. They call this a right triangle because it has one right angle. And we define the points at the vertices and the lengths of the sides according to this illustration, and the angle theta we put right there. The side S is one of the adjacent sides of the right angle, and S in this case is the base of the triangle. The other adjacent side has length T, and that goes up. That's the the height of the triangle, T. And U is the length of the longest side, called the hypotenuse. The hypotenuse. Now, I don't know where in the world that word comes from, but that's what they call this longest side of any right triangle. So we can define various ratios: S over U, T over S, U over S, but we're interested only in two particular ratios. The ratio T over U, that is the height, divided by the length of the hypotenuse. That's how we define the sine of this angle theta. Similarly, we define the cosine of the angle theta as the length of the base divided by the length of the hypotenuse. Now, this particular model, the right triangle model, may seem intuitively easier to most people, and when I wrote my book Trigonometry Demystified, the original edition, I started with the unit circle model. And strangely enough, even though I thought that's easier to understand and more versatile because it defines these functions for all angles all the way around the whole circle, whereas the right triangle model is limited to angles greater than 0 and less than 90. Because if we make this angle 0, we don't have a triangle anymore, and if we make it 90, we don't have a triangle anymore. We only get a right triangle if this angle has a measure greater than 0 degrees and less than 90 degrees, so it limits this definition considerably, the right triangle model. But again, the sine of theta is the height divided by the length of the hypotenuse. The cosine of theta is the length of the base divided by the length of the hypotenuse for all angles greater than 0 degrees but less than 90 degrees. So that's how it goes, and you might intuitively see the resemblance to the unit circle model because the sine is the y-coordinate, which goes along the vertical axis, and the cosine is the x-coordinate, which goes along the horizontal axis. So watch that video, why don't you? It's called the unit circle model. Stan Gibilisco, signing off for now. Until next time, so long.